So welcome to this latest video on 162 Maths, and in this video we'll be going over the GCSE Maths higher topic of proof. Now as always, I'll include a copy of the questions that we go through in this video as a link in the description below, along with any lessons that are equivalent to this particular topic. Now before we go through some past exam questions related to proof, let's just have a quick overview over some of the basic things you need to know, and to also help you revise and understand and kind of tackle these questions, as they can be very high level and also worth quite a lot of marks. Now with proof questions, what you want to do is be very general. You want to be very universal in your explanation. So if you are picking particular numbers, the proof may only work for the numbers you've chosen. So ideally what you want to do is represent a number with a letter, which therefore represents any number. So typically we tend to use, with algebraic proof, the letter n, which represents number. So here, if you want to represent a consistent row of consecutive numbers, then here what you would do is, if n is your choice of number, then the next number would be n plus 1, and the next number would be n plus 2. So there's three consecutive numbers. Alternately, you could have started with the previous number, which is n minus 1. And again, to get consecutive numbers, all you're doing is just simply adding 1 from one term to the next. And obviously from this one, we take away 1, but if we're going in the opposite direction, we're still adding 1. For even numbers, well, any number times 2 is going to be an even number. So here, if we represent an even number as 2n, then the next even number will be 2n plus 2, because you can't have 1, because if n is, let's say, 3, then 2 plus 3 is 6, and then the next even number is going to be 8, so it's going to be 2n plus 2, and then the next consecutive number is going to be 2n plus 4. So here, for consecutive, we're adding 2, which is the smallest even number that we can possibly add. Then for odd numbers, again, any number times 2 will give you an even number, but if you add 1 to it, that's always going to give you an odd number. So whatever value n is going to be, whether n is odd or even, 2n plus 1 is guaranteed to give you an odd number. So here then, consecutive odd numbers will be 2n plus 1, 2n plus 3, 2n plus 5, and the next consecutive odd number would be 2n plus 7. Then for square numbers, again, that will be represented with n squared. So then if you're wanting a consecutive square numbers, then the first one will be n squared, the next one will be n plus 1 squared, and the next number would be n plus 2 squared. For multiples of 2, well, any multiple of 2 is going to have 2 as a factor. And any multiples of 3 would have 3 as a factor, and again any multiple of 5 would have 5 as a factor, etc. Now when you are multiplying numbers, an even number times an even number will always give you an even answer, regardless of what number it is. An odd number times an even number will always give you an even answer, and the only way of getting an odd number when multiplying is odd multiplied by an odd will always give you an odd number. Then also an important one is a multiple of n times another multiple of n will always equal a multiple of n. So here again, if I wanted to show that 2n plus 4 is a multiple of 2, well, this is always a multiple of 2 because you're multiplying by 2, and 4 is a multiple of 2. So therefore, when n is any number and you substitute it into this expression, the answer will always be a multiple of 2 or an even number, because any multiple of 2 is even. Now, another linked topics to this particular proof question are going to be algebraic fractions, simplifying expressions, so in other words, collecting like terms, solving quadratics, notably difference of two squares, but also looking at converting recurring decimals to fractions and vice versa, and common knowledge of factors and multiples. So let's get started working through some exam questions. Now, a little reminder that if you want access to the questions, all you need to do is simply click on the link in the description. Now for question 1, there is an error in the question. Now this numerator is actually incorrect and should be written as 6 minus 14n. So a little correction there. So looking at this, what we need to do is show that the left hand side equals the right hand side. So if I take that left hand side, now what I want to do is again have a common denominator and write these as a single fraction. So I'm going to multiply this first fraction by n minus 2, and I'm going to multiply this second fraction by n over n. So then what that leaves me with is 4n minus 3 multiplied by n minus 2, and that's all over n minus 2, minus, and it's going to be n times 4n plus 3 over n minus 2 times n. Now for this, what you need to do is just be careful of the negative. So here, expanding these two brackets, what I end up with is 4n squared minus 8n minus 3n plus 6 minus 4n squared, and it's going to be minus 3n because I'm multiplying by minus n, and that's all over n minus 2. I'm not going to expand the denominator because, as you can see in the answer of the right hand side, it's been factorised. So all that's left for me to do is then simplify. So the 4n cancels with the 4n squared, and then joining the n's, I end up with minus 14n plus 6 over n minus 2. And just swapping the numerator terms around, I get positive 6 minus 14n over n minus 2. And there we go. Moving on to question 2, it says prove algebraically that 7.67 recurring converts to a fraction of 691 over 90. So again, making the decimal equal to x, I then multiply both sides by 10, so I get 76.7, multiplied by another 10, so I get 767.7 recurring, and then taking these two things, I get 100x equals 767.7 and 10x, which equals 76.7 recurring. If I take the two things away, I get 90x equals, and it's 691, so x equals 691 over 90. Then for question 3, it says prove that the sum of 3 consecutive numbers is a multiple of 3. Well, if the 3 consecutive numbers are going to be n plus 1 and n plus 2. So the sum means we add them together. So joining these three things together, how many n's have I got? Well, I've got 3n plus 3. Now this here is a multiple of 3. And this is a multiple of 3. And a multiple of 3 plus a multiple of 3 equals a multiple of 3. Alternately, what I could have also done is with this is factorized it and got this, and then you can then say that if 3 is a factor, then it must be a multiple of 3. So any of those two explanations would be absolutely fine. Moving on to question 4, it says prove algebraically that the sum of the squares of 2 consecutive even numbers is always 4 or more than a multiple of 8. So let's have a look at this one. So looking at 2 consecutive square numbers, well, one consecutive even number is going to be 2n, so the next consecutive number is going to be 2n plus 2, and I want the square of those two numbers. And I also want to add them together. So adding them together, well, 2n squared is 4n squared. And then if I multiply this out, this recognize that that is double brackets. So then multiplying that out, and again, just taking a bit of a shortcut, I get 4n squared plus 8n plus 4. Then neatening all of this up, I get 8n squared plus 8n plus 4. So what I can then do is I can then factorize these two things. So I get 8n squared plus n plus 4. And then from this, looking at what it says that it's always 4 more than a multiple of 8. Well, all of this is a multiple of 8 because 8 is a factor. And this is always adding 4. So there I've proved that this statement is this here. Moving on to question 5, it says x is an integer. Prove that 18 plus x plus 1 all squared plus 2 lots of 2x minus 5 is a square number. So for this, what I need to do is expand the brackets. So I've got 18 and I've got x plus 1 squared, which is x plus 1 plus, and that's going to give me 4x minus 10. So then expanding this out, I get 18 plus x squared plus 2x plus 1 plus 4x minus 10. Collecting all those like terms together, and I get x squared plus 6x plus 9. And then from this, I can then factorize this to give me x plus 3, which can also be written as x plus 3 squared. So therefore, this is a square number for all values of x. And there we go. Moving on to question 6, it says prove algebraically that the difference of two consecutive numbers is an odd number. So again, looking at this, we're looking at two consecutive square numbers. So two consecutive numbers are n and n plus 1. I want to square those numbers and I want the difference. Now, n plus 1 is the bigger number, so let's just write that one first. And then expanding this out, well, if I expand that out, I get n squared plus 2n plus 1 minus n squared. And the n squareds are going to cancel, so all I'm left with is 2n plus 1. Now, 2n is always an even number because it's a multiple of 2. And 1 is always an odd number because that's never going to change. And an even number plus an odd number is always going to equal an odd number. And there we go. Moving on to question 7, it says c is a positive integer. Prove that 10p cubed plus 40p all divided by 5p squared plus 20 is an even number. So for this, what we need to do is factorize both the top and the bottom. So looking at the top, a common factor there is 10p. So 10p, and then factorizing it, I get p squared minus or plus 4 all over. And then factorising the bottom, I get 5, and it's going to be p squared plus 4. So from this, you can see that the brackets are the same, so they cancel out. So it becomes 10p over 5, which then leaves me with 2p. And this is always going to be an even number. So always even as it's a multiple of 2. Moving on to question 8, it says n is a positive integer. Prove that n squared, plus 3n plus 2 must be a multiple of 2. So for this, we can just do this by explanation. So here, if n equals an even number, then n squared plus 3n plus 2. Well, an even number squared is always even. 3 times an even number is going to be an even, and 2 is an even. So an even plus an even plus an even is always going to equal an even answer. Then and if it's even, then it's going to be a multiple of 2. If n is negative, if n is odd, then n squared plus 3n plus 2. Well, an odd number squared is always an odd number. 3 times an odd number, well, that's still an odd times an odd, which is odd. And then plus an even. Well, an odd plus an odd is even, and an even plus an even is going to equal an even number. So therefore, a multiple of 2. So there you can see that regardless of when n is positive, even or odd, it's always going to equal an even number, which is therefore a multiple of 2. Alternately, what you could have also done is recognized and factorized this as n plus 2, n plus 1. Now these two things here are basically two consecutive numbers. Being multiplied. Now when you've got two consecutive numbers, therefore one must be even because obviously 1 must be a factor of 2. So therefore must be a factor of 2. So again, another way of explaining this, and for the full marks you really do need to show that for all values it's going to give you a even number. Now fortunately you will not get any marks if you substitute numbers in. You'd have to use algebraic terms to get the full marks for this particular question.